Hello, this is Group 95, and today I'll be going over the 9 points for the video presentation. So to begin, we use PostgreSQL and pgadmin for the database. As for the web app, we used Node.js, TypeScript, React, and Postman. For the relational schema, here is deliverable one's relational schema. There's been quite a few differences. Phone numbers is a multi-value attribute, so that's its own table. And that has a foreign key to one of customer, employee, hotel, or chain ID, chain IDs, not two, just one for each one, or one at a single time. Amenities, for the same reason, is its own table because it's multi-value. And I also want to show an example. Select from phone numbers. So you can see the ID can only be one at a time. You cannot have two foreign keys be filled, just one at a single moment. Where was I? Amenities, also its own table. And there's another table, room amenities, that will link the amenities table to the room via IDs. So on here, we see select amenities. Select from amenities. So that's all the amenities there. It's not linked to anything, but that's what room amenities is for. So that will link all the different amenities to a certain room. There's also a payments table that will document the customer ID, amount, method of payment, date, stay type, and the stay ID. Next up, for major constraints, of course, the primary keys, the format is name of table, ID, and which is serial. That applies to pretty much every table. A few exceptions are room amenities and phone numbers. These tables are dependent on others to exist, so their primary keys are made up of other attributes. Foreign keys, like I said, room amenities have foreign keys. As an example, this will reference the amenity table, with the primary key being amenity ID, as well as room table, the primary key being hotel ID and room number. So these are the SQL or the statements you can put in the query tool in PostgreSQL on pgadmin. You just use the foreign key as well as the references keyword. Value constraints, these are very important. These check things such as total rooms in a hotel being more than 0, rating between 0 and 5, price greater than 0 inside your rooms. So when you create the table, you just need to add a statement at this section, check that these conditions are passed. There's also unique constraints. For example, the zip code, it's not a primary key, but it should still be unique. And that's in hotel, hotel chain, customer, and employee. Email is another example of a unique attribute. So when you create the table, you just need to add these into the values that you add. Others, you might recall that the stay type can either be booking or renting. Views can only be sea or mountains, so we just use enum types so that we can set the type to either sea or mountain, booking or renting. Next up, what data do we populate the database with? So it just corresponds to the deliverable instruction. We see there are 5 chains, hotel chain. There's also a test chain that I did when we were first making it. There's 8 hotels per chain, so you do this, total of 40 hotels, as well as 5 rooms per hotel. You can see these are all randomly generated. Well, there's a bit of a pattern, it's not exactly random, but they are all situated in the capitals of a province in Canada. So codes will all be unique, all of them have 5 rooms, and that would bring our total to 200 rooms. So there we go. All these are kind of random. Capacities between 1 and 4. Again, there's constraints, so that capacity can't be less than 0. So moving on. For simplicity, we did focus on 8 hotels of just one singular chain. So there's only 8 employees total, 1 at each hotel. Along with that test employee right here, they're all managers. You can see for the foreign key, work ID, that references hotel ID and hotel. They're all different. We also have 8 customers. Oops, little typo. Customer. There we go. And they all have 8 different stays, 1 for each customer at a hotel, and 8 payments that correspond to each stay. Moving on to 5, show some queries. So for example, I thought that a customer might want to look for rooms under their $225 budget. So simple query for that is this. So select all the rooms with a price less than $225. You could maybe also search by address if you use the join statement, or join keyword rather, for the hotel. So you could just get the street address and all that. Another query, an employee might want to see how busy the hotel is during a certain time period, for example, March break. In this case, since there's only 8 stays, none of them happen to correspond with March break, so the hotel is probably going to go bankrupt pretty soon. Number 6 is to show a trigger. I decided a trigger that would be pretty easy to do is to prevent inserts on stay when the date overlaps with an existing stay. So here's the trigger function, first of all, and essentially it just selects from stay where, here it is right here, the overlap, and matches ID with ID, number with number. and it raises this exception. We just create the trigger, so it checks the function before we insert, and then we test. So you will see, select from stay. This is the target one that I wanted. So January 25th to January 26th at room 0, hotel 2. So this will fail because January 25th will overlap with room 0 at hotel 2. So that's an example of our trigger. Number 7 is to show indexes. So those queries I did earlier, those might take a long time because of the size of the stored data, especially because the hotel stores the data forever, even after the stay. So for example, the ones I did earlier I want to do first. Querying rooms based off of price. So I just create an index for price, for capacity as well maybe. And for planned duration, there's another index. You could also maybe be a customer, or be an employee rather, who is querying for phone numbers. So you can make an index for that as well. And number 8, views. This is the last one that I'll cover before we move on to the web app. So we'll start with available rooms per area. Since all this data is from the database, like I said before, we want to take all the stays where the current date is within that start and end date, and then we look for rooms that do not match these stays. Then we can just simply join hotel, so we can get the area and query by area. So that's all the stuff for hotel. This is all the stuff for room. There's our join statement. So we can match the address to it and search by area. And where is it? Here it is, yeah. We're current date between start date and end date, and we want to look for rooms that are not in that sample. So we can test this out. There should just be one, yeah, just one available room. It's our, right here, where city equals Ottawa. The current date right now does not conflict with the current one inside the database. Oh, I keep forgetting my from keyword. So this would be the one in question, but because that's not currently, that's not the current date, this should be available to us. Aggregated capacity of all the rooms in a specific hotel. Yeah, this is just the total capacities. So we join the hotel with room, so we can sum all the capacities. So we create an alias total capacity for sum of the room capacities. We just join the hotel, and then we group. So here's our test case, really quick. And there we go. All the rooms are about capacity 1 to 4. There's only 5 rooms per hotel, so this checks out. Point number 9 is to show the user interface, and we're going to move on to that with Bariq.
So first, once you go to the landing page, you will find this drop down to select your role. You can either be a customer or an employee. So let's start with the customer. Once you select the customer, you are able to search for rooms based on different categories. So let's try and search for rooms where the capacity is 3. So if we click on search, you will see all the rooms where the capacity is 3 or more. If we go 4, then we're left with fewer rooms here. We can also search based on combined categories actually. So if we go, price is 200 and the city is Ottawa, then you can find only one available room that matches these 2 conditions. And as you can see, this handles if the user inputs like different capitalization than the one that is stored in the database. You can also search your rooms based on the start and end date. So let's take this for example, actually, since that's we are at it. So this one is room 111. It's in Ottawa. Currently, we can see it once we search for it. If we go to the database and we go to state table, which is the table where we keep track of our bookings, and if we look at 111 room, which is the one that we were looking at in the UI, this one is taken from April 4th to April 5th. So because it's booked, what should happen now if we search for rooms between April 4th to April 5th that are in Ottawa, and we know that we only have one room in Ottawa actually. So if we search for this, we're not going to have anything because remember, this room is actually booked. However, if we change from April 11th to April, let's say 15th, and click search, then we can see the room that we were looking at. So in addition, a customer can also book a room. So if we click on book, the customer will get this form where they can put their data. So for now, I'll put demo for the, no need to fill the middle name, demo for the last name, demo for the email, streets, and the dates are already selected based on the search that we chose. We can have any postal code. And if we we click submit, it says that your booking is successful and that you will pay upon arrival. So if we go now to the stay table and we execute the script, you will see that this booking is now in the database. There's the customer ID 44. So if we go to the hotel customer table where we keep track of our customers and execute the script, you will see that the customer ID 44 has been registered, their first name, their last name, and these are the data that we filled. So actually, every time we make a booking, we update these two tables, the stay table for the bookings and the hotel customer for the info of the customer. And since we are looking at this, the tech stack that we used is actually Node.js, TypeScript, and React for building the application. So on the server side, we've been using the Node.js to make all the requests and build the API endpoints. So all the post, delete, and get requests are made here. And for the server side, we're using React, so we have these components that we will be actually going through shortly. So that's basically it for the customer parts. Going to the employee part. So once you are signed in as an employee, you have the option to add a payment for a specific booking. So if we go back to the stay table and we run this query, so this booking that we just made has a stay ID of 17. So if we put the stay ID, we put the amount. We can choose any amount actually. It doesn't have to be the same amount that the listing was for. So the employee is expected to put the correct amount, but just for the demo's sake, we'll put 3 sevens just to make it easier to show this in the database. Payment method could be cash. Date could be, let's say, tomorrow. And the customer ID is 44. So we can either select booking or renting. For now, let's choose renting because in the guidelines, whenever the employee makes a payment, it changes from booking to renting. Before actually doing this, let's go to the payment table. So this was the last payment that was made. And if we add the payment now, it says that the payment was added successfully. And if we run this query again, you will see that this payment has been added to the payments table that we have in our database. So this is a feature that the employee can do. Another thing that we have is if the employee puts an incorrect stay ID that is not in the stay table, so if there's no booking, obviously, if let's say he tries 20 and adds a payment, then it says or adding a payment. Another thing that the employee can do is view the payments. So once they click on the view payments, they can see all the payments that were made. The last one was not added here because we need to refresh. Now you can see the last payment made, and they can have the payments and also view the bookings. So once they view the bookings, they can see the stay ID, the start and date, the booking type, the room number, the hotel ID, and also the customer name. So this one is the last one that we added, which is demo. And here's actually the query in which we joined the two tables, the stay table and also the hotel customer table to get the first and last name for each specific booking. And I think in the server side, if we go here, that's part of actually that's part of the GET request made to the stay table, where we combine the customer first name and last name. So we're combining the two tables, the hotel customer and the stay table based on the customer ID. And we've also verified that all our endpoints are working as expected through Postman. So this was also part of our tech stack. So we've used Node.js, TypeScript, React, and also Postman as a tool to verify our endpoints. So if we search for stays, for example, and we do a GET request, you will see everything coming back as a JSON, all the bookings that we have in our database. Similarly, if we look for rooms and so on. So that's mostly it for the web application. We will also leave a link for our repository in the report. Here are the prerequisites to run the project. You need Node.js, you need Postgres, and hopefully this should be enough for running the application. And yeah,